Hello, alrighty. So, the whole theory that I have for this panel is that all the talks that we just saw, they're sort of like movies. This is more like the features on the DVD. This is something to go, get to know these guys. This is something to sort of. I hope that if we don't answer any of these questions and we just sort of go with the flow, I'm totally okay with that. Um, this is just to go with the flow, just something interesting. So, we already sort of have an intro, so I'll just run through these intros really quick. Right here we have Ben Fish. He's the CEO, co-founder of Espresso. He's also an assistant professor at Yale. He has some incredible research that is widely used today. So proof of replication, I just learned this for Filecoin. Literally the most used, I'm supposed to talk on a microphone. Literally the most used ZK proving system today. No big deal. Also VDFs and even some economics research on mining. Really great work. We also have Connor. So Connor is just a general purpose gigabrain. I have learned so much from him. He's the CEO of Rollkit, apparently. He's an engineer and a researcher at Rollkit. I've learned a ton from Connor about how you actually decentralize rollups and without using consensus. So you use something like fork choice rules. It's really, really interesting work. And you've also done work with MPC, and you were a guitar teacher. Yes, so he can riff. Okay, and then we have Josh Bowen. So Josh, you are known, I think, for your width and depth of knowledge, which is rare. You've done work, again, some research at Celestia on execution environments, fraud proofs, optimistic rollups, and before that you were at EdgeNode, right? Yes, and then before that, we don't want to talk about that. No, okay. That is at Google. He worked at Google. Okay. Okay, so the first question is, what is love? No, I'm just kidding. This is not like the Lex Friedman podcast. Um, but
we could talk about that.
Yeah, okay. The first topic I really want to get into is not really comparing which is best with like consensus and decentralization. But one of the really interesting things with this panel is that we have 3 shared sequencers, or with Rollkit, a way to build shared sequencers as a rollup, but they're all in very, very different contexts. So it's like all of these folks and all these projects are incredibly smart, but they made different decisions based on that context. So if we can dive into the why and the how of why we used the consensus algorithms that we used, then I think that gives us a better understanding over the problems that we're trying to solve, which of course shows us what shared sequencers actually do. Because sometimes if you go on Twitter, one of the leading questions is just like, WTF is a shared sequencer? So we can just go in order. Ben?
Sure, yeah. So the way that I view it is if rollups are built on top of the layer 1, then the default shared sequencer should be the layer 1. If it's not the layer 1, what are you doing, right? Well, you're trying to do something that the layer 1 doesn't provide. So if you're trying to build rollups on top of Ethereum, and I'll talk about building rollups on top of Celestia in a second, but if you're trying to build rollups on top of Ethereum, Ethereum's a dynamically available protocol, meaning it's very available, it works even if 10% of the network is online. It has very slow 15-minute finality. So we decided that, well, what does it make sense to build for a shared sequencer that is not the layer 1 but sits on top? Well, something that provides a different property, and that's fast finality. So that's what Hotshot, our consensus protocol, does. It optimizes for getting 12,000 validators to be able to reach consensus within a few seconds. It sacrifices the availability guarantees that Ethereum has in the sense that if less than 75% of the network goes offline, then it may not make progress. But that is the reason we did that. If you were building a shared sequencer on top of a different L1 like Celestia, which uses Tendermint, then it may make sense to use something else, right? Tendermint, we didn't decide to use Tendermint because Tendermint is not optimistically responsive. That's like a separate discussion. It's like it can have fast finality, but it doesn't necessarily scale to as many nodes if you want to retain those fast finality guarantees. So Hotshot's designed to scale to Ethereum's validator set because we want to be as close to the L1 as possible, just providing a different property. In this case, fast finality instead of high availability.
Never thought about using RollKit as a shared sequencer. That may be a possibility, but we're more interested in using shared sequencers with RollKit. RollKit is meant to support all different kinds of sequencer schemes because we've identified many, and the trade-off space between them all is unbelievably complicated. So we like shared sequencers a lot because one of our goals has been to allow people to launch chains without needing to provision a validator set. And when you've promoted that idea and got everyone excited about it, and then they find out they have to have sequencers, then it doesn't seem as cool anymore. So you can do a rollup without sequencers easily if you do the based rollups, the no sequencer rollups, but those inherit the block time of the L1, which on Celestia is 15 seconds. 15-second finality, 15-second blocks. A lot of people want to go faster than that. When people think about rollups, they think about Arbitrum and Optimism, which give very quick soft confirmations and provide a very fast UX to the users. And if you lose that when you go to develop a rollup, you're going to be sad. So shared sequencers let us do this no validator set, easy to launch, and also have the fast user experience. So shared sequencers are probably one of our highest priorities to integrate into RollKit as soon as possible.
Yeah, so kind of just reiterating what the other panelists have said, right? Like, I take a much more kind of like practical background. Like, I'm not an academic by any means, and so the evolution of Astria as a project came out of my work at Celestia. And broadly, what we were working on was like, how do I deploy a rollup on top of Celestia, and what are the components necessary to kind of do that, right? So we go look at like, why are there sequencers in like Ethereum rollups? We've all seen like the based rollup design mechanism, right? But the fundamental reality was that users would prefer faster response times than slower response times. I often reference, right? There's some research from like 1991 on like how do users feel about like user experiences in like web applications, right? And like roughly it says users want to click a button and expect it to respond within like 1 to 4 seconds. Shorter is better. There's probably more modern research on like mobile UIs, right? Everyone's used like an older phone, or like iPhones are known for having like much faster latency and it feels kind of smoother, right? But users like responsive user experiences. To Evan's point, right? With these centralized rollups, we got these very, very fast responses. And again, I'm kind of cynical or like, I view it as practical, right? If we want to say, hey, we have these centralized sequencers, we want to decentralize the sequencers. If you sacrifice the latency benefit, that is the reason they moved to centralized sequencers in the first place, users are going to say, oh, this is just like a degradation of my protocol. No one in like a rollup wants to be like the first mover to say, cool, I'm going to use the shittier experience that my users like less than the centralized ones. So it's kind of our job if we think decentralization is important, then we need to provide a user experience that is adequate, that users will actually use the damn decentralized thing, because I am not optimistic that users are going to be just like altruistic actors who say, no, I use the thing that is the most decentralized. Like, no, they don't. They use the thing that is convenient for them, that makes their life easy. We need to provide a decentralized solution. And I think shared sequencers are a way to do that while minimizing, again, it should be easy to deploy a rollup, right? We can't have everyone do this problem. Like, if we want 1,000 rollups, we can't have every single project need to do this process every single time.
Yeah, if you, going back to the point of like taking away the fast responsiveness, have you guys ever taken away ice cream from a child? It's like, it's not fun. Okay, so next topic. Another way to think about a shared sequencer is it's a committee, and it can perform some sort of service for rollups as a committee. And specifically, like, there's just like a lot of different services that you can provide doing that. For example, like with Espresso, you can provide DA. And with Astria, as far as I understand, you can do something like IBC and like settlement, like with the EVM portion. So I'm curious to dive into what are the other committee-based services that we haven't already touched on, or what are some committee-based services that you think would be useful for rollups? So again, we can just go in order.
Yeah, well, I mean, it's interesting that you think of it as a committee. I mean, the committee if the committee is like 12,000 nodes, or if there's the same set of nodes as the underlying L1, then it's not necessarily a committee. It's the same physical set of nodes, but it's logically playing a different role of offering a modular component of the overall services that a rollup needs. Primarily ordering, and then availability can come for free as part of that. But then you bring up a good point, like what other services can you get from an ordering layer? So we've been talking about in our talks how shared ordering layers like Espresso, like Astro, also give you interoperability guarantees. Beyond that, if you could think about adding validity checking as well. So what if rollups could also just settle directly to the shared sequencing layer? Then you might ask, well, what is the layer 1 doing, right? Well, the layer 1 is still there. Perhaps the layer 1's being used for availability. But the layer 1.5, for some reason, is better at providing, for example, it may be easier to add a custom opcode to verify ZK proofs at the layer 1.5 that is faster. It really depends on what you want to move between the layers, because the layer 1 can provide all these services as well.
I can't think of anything we want besides a fast, dumb, decentralized ordering machine.
Okay, I'll give a more optimistic take. I guess, like fundamentally, I view shared sequencers, and this is going to my kind of like cloud SaaS, enterprise SaaS background, right? And this is the land of middleware, right? Like when I joined crypto, I think one of the weird things to me was like, you know, the architecture was like, oh, there's like Ethereum, and then you just like slap a UI on top of Ethereum, and I'm like, that's not what enterprise architectures look like. There's like 13 layers between like an enterprise service bus and like some Oracle DB from like 2 decades ago, right? And like the mobile app you use to check your insurance, right? Layers exist, and middleware is used to kind of intermediate between these and to like reduce complexity of interactions with like a broader kind of ecosystem of things. So if we think about shared sequencing, again, it's a committee. What can you get from this committee? I think of it as like, you know, we've used the term decentralization as a service, but also it's like, what can a roll-up get for free by using a shared sequencer? Again, it gets these soft commitments to like my talk, right? There's bridging benefits. If you say you still need some kind of bridging guarantee of like the canonicity of this chain, this is less useful if you're doing like a settlement to like Ethereum thing, right? Where you say, well, okay, you know, is the rollup defined by the bridge? Well, the bridge on Ethereum has control over the ordering of the rollup in some mechanism, then that's fine from a bridging. But if a rollup wants to bridge to like some extra domain space, it's going to need to make an attestation of the canonicity of its given fork to that receiving chain. We could also think about things kind of like farther out, like, okay, is an oracle, you know, is it a roll-up of like the shared sequencer or whatever, but you could say part of the data stream of this shared sequencer is some set of oracle transactions from off-chain. How is that happening? Is the committee of the shared sequencer having, you know, an increased amount of state and actually making some claim over the validity of, you know, this off-chain data? There's various things like that, but I think really the way to think of it is like, it's a stream of data. Generally, we assume the rollup is only kind of filtering out the stream of data directly relevant to it. There is potentially data you could push into that stream that gives a shared timestamp of it across all the rollups that they may choose to filter out as well. So again, you could have some JSON format for Oracle data, and all the rollups of the shared sequencer can choose whether or not they want to parse out that Oracle data and use that in their state machine. There's a pretty broad design space there, but it's unclear what will be like useful. And I think the research on like what are the kind of trade-offs and security guarantees and whatnot of these things, but like I don't think we're solving the Oracle problem here. But there's potential like UX benefits as like a rollup developer.
Yeah, that's really good. One of the things that I was to lead into the next topic is MEV and PBS specifically. So some of the things that I was trying to hint at is with these community-based services is that whenever you use a shared sequencer, and if that shared sequencer is using some sort of MEV infrastructure, that MEV infrastructure is like sort of already set in place for you. So to get into the MEV part, monopolies are bad in general. That's usually a safe thing to say amongst crypto people and most folks in general. But we don't always get rid of all of the monopolies. And I think, especially from Ben's talk, where you had some really, really good answers to this. So I really want to dig into monopolies and basically profitable censorship. So we still rely, so crypto, like we like to think about getting rid of monopolies, yet we have, each proposer has a monopoly over which block is used for that given slot. So I kind of want to dig into who captures MEV in the system and how can we change that to be more programmatic? And no matter which direction we want to go in, how can we change that? So yeah, we can just, again, go in order.
Yeah, I mean, this conversation is relevant even just talking about layer ones, like without rollups, but the same problem happens with shared sequencing layers for rollups too. So it's interesting that you said, wait a minute, the proposer in a consensus protocol has a monopoly on a slot. It gets to decide what goes into the slot. So this is, I think, one of the really interesting things about consensus protocols. There's a number of papers on this. Like there's a paper called "Monopoly Without a Monopolist." A blockchain is a monopolist. A proposer has a monopoly over one single slot, right? Does this slot-based monopoly behavior achieve monopoly pricing? Meaning, do users pay for pay the price that maximizes the revenue of the blockchain, or do they pay basically the market clearing price where supply equals demand? And so, ignoring MEV of ordering and sandwich attacks and all that, right? If we just look at what's the price to include a transaction, EIP 1559 has solved this problem. Users pay, even though the proposer in the consensus protocol has a monopoly, users pay the market clearing price. And the reason is that if the proposer is not willing to process the transaction of a user paying the market clearing price, the next proposer will. So having a monopoly for a short period of time does not give you a monopoly over prices and this is the key property of blockchains. That's why they have to be decentralized, right? Because I'm elected once in a blue moon to process a block, if I don't take the transactions as they are paying the market clearing price, there's someone waiting in line who will just do it. So I cannot make a credible threat to users to reject their transactions paying below market clearing price. Now, when it comes to MEV, this isn't the case because the transactions are available to me. I can sandwich attack them. I could even get the help of a bunch of builders and searchers to figure out how do I extract as much value as possible by reordering the transactions in front of me. The willingness of a proposer in a later slot to do it without extracting value doesn't matter. I can do it now because the transactions are there now. And that's why we need to move towards order flow auction design, where we introduce an ideal functionality that has a privacy element to it, which shields the transactions from the proposer, builds a system which is ideal and stable for users so that all users submit their transactions there. And then we turn the proposer back into a passive entity that can either take the block output of this ideal functionality or have nothing at all. And again, that proposer does not have the ability to make a credible threat to users to not take their transactions if they send it to the ideal functionality. They just try to take anything that's available to them at the time. And it's very hard to design those ideal functionalities. It involves a lot of cryptography, perhaps trusted execution environments, but that is the direction the industry is going in. That's what Flashbots and Suave are working on, and those only work with highly decentralized ordering protocols. That's why we're advocating for shared sequencing.
So to respond to that really quickly, it's like we in theory you have multiple different builders, so maybe multiple different swabs or something like that. And the proposers, since they do still have this monopoly for this one block, it's very short and it's very limited, they still can pick the block that gives them the most profit. So this is sort of where I was.
But the block that gives them the most profit may be the one that has all the users. And the one that has all the users is the one that is shielding users from MEV. So you can either design something that's stable for the proposers, or you can design something that's stable for the users. If all the users are participating only in the order flow auction that gives them the best execution price, the short-lived proposer has no choice but to take from that pool. Otherwise, it doesn't have any transactions to process. It can't make a credible threat to users to say, no, don't submit there, I won't take it, because it has a short turn and then it's gone, right?
I guess I was proposed like the spicy like counterpoint, right, of like dumb flow is dumb, I guess. And like what I mean is that like generally when we think about like retail flow and like users getting sandwich, it's because they're like unsophisticated actors and like they're not necessarily doing like the labor to find what is like the optimal execution for them, right? And then there's also like we can think about user preferences in like financial senses, but like also in like a product sense, right? So like I spent like years at Google, right? Like what does Google do? Well, Google provides you a lot of free services. But like, are those services free? No, Google's monetizing that on the back end with ads. And why are they doing that? Because users don't like friction, and transactions are friction. You know, crypto talks a lot about transaction friction because if it's like $2.50 to submit a transaction, you won't do it. Well, like when apps came out, like the App Store on like Apple, right? It was like 99 cents to like buy an app or whatever. That's like no money, right? Like functionally use an app for like 10 minutes, you should be willing to pay $1 for it, right? But people didn't. So they made them all free, and then they monetize on the back end. Users trend towards things that are low friction, and then they monetize on the back end. We see this in financial systems, right, with like Robinhood and payment for order flow, right? Users don't think and they don't read the MBA papers that say like, hey, maybe it's suboptimal for you to actually be like submitting transactions that are free, and then you get like marginally worse execution, though the actual quality of execution on payment for order flow seems to be like an unanswered open question from like analytics and like availability of data. But like, fundamentally, like users use the thing that is low friction, not necessarily like the thing that gives them like optimal execution. So I think like again, like I'm very positive on like Suave and like Flashbots, but I think it's going to be a very hard fought battle to say we are able to convince users that they should only submit transactions to this if that may result in some marginally higher transaction cost for the user, and then someone else comes along and say, I will ruthlessly front run and sandwich you, but you will not pay any upfront transaction fees. The users might say, yeah, all right, I'm fine with that. So I do think there is like something from like a product perspective that may be like trickier to get from like user demand rather than the kind of like, again, like the ideologically like corrective, like we just need all the user flow to go through one of these kind of like TEE environments, and therefore we can't do all the sandwiching attacks when you're like, what if the users just like don't care?
I think we're moving the target. I mean, whatever is good for users is good for, like, let's define what's good for users. That's the ideal functionality. Maybe it's not paying for failed transactions. Maybe it's not paying monopoly prices, maybe it's both. But if we design something that's stable for users, then that will be stable for a blockchain too, only if it's decentralized, and that's the key point. Yeah.
Yeah, and I agree on that. It's just like defining what is actually a user preference across like many parameters is like hard.
Agreed.
If you use a lot of people talk about rollups inheriting liveness and censorship resistance from their base layers. We found that if you build a sovereign rollup on a DA layer, which is built such that it inherits censorship resistance and liveness from its base layer, fundamentally you leak a form of MEV to the validators of the base layer called profitable censorship. And if you don't want to leak that MEV, because maybe you don't want to create anything like gas wars on the base layer, then you can't inherit liveness and censorship resistance from the base layer. So if you're using a shared sequencer and your shared sequencer has its own consensus and its own proof of stake and its own token, the cost to create a liveness failure on the shared sequencer is the cost of 1/3 of the stake if it's Tendermint style. And that could be very high. That could be high enough that rollup developers don't feel as though they need to build a forced transaction inclusion mechanism from L1. It might be censorship resistant enough on its own. And so the shared sequencers can help remove that MEV from DA layers.
This is really, really good. Before we finish it up on MEV, do you all envision any way for a rollup to be able to capture its own value just like that? Like what would be like more of like a mechanism design for a rollup programmatically capturing MEV as opposed to only relying on something like Suave or whatever's built into the shared sequencer?
I mean, I think that if a rollup is using a shared sequencer, then the shared sequencer becomes part of the rollup's protocol, and so it does need to be programmed into the shared sequencer. You can always view things as rollups participating in some kind of order flow auction. So if you do design order flow auctions, then maybe there's a way of doing it without programming it into the shared sequencing protocol. But I think that that's the opportunity that we have right now. So one of the ways we didn't really touch on, and none of us really touched on this in our talks, but with base rollup, if you use the L1, then there isn't really a way of programming into the base layer like, oh, rollup should get back this portion of MEV. We, designing these decentralized protocols on top of the layer 1, have that opportunity now. And I think it's important for adoption. It's important for at least the major rollups out there to be convinced to use Espresso or Astria or Rollkit, right? An important thing to do is to say, here's a credible revenue sharing protocol in place that can allow you to get back the value that you're creating for the system rather than the system taking all the value. And so that is, I think, a very important research problem that I'm trying to get people excited and interested in. We have some thoughts on that. I shared a little bit in my talk. You can have like alternating blocks where in some of them you run independent auctions, some of them you run joint auctions, independent being one for each rollup, joint being auctioning off wholesale blocks for all the rollups at once, and that allows you to estimate and approximate the marginal contributions of each more directly, and then use that to inform some reallocation strategy. But this is a wide open problem that welcome everyone to think about and offer better solutions on.
We think a lot about how you can do MEV redistribution and things like that, and we suspect that the way it might work is if whatever layer is doing your transaction ordering has really good censorship resistance, maybe with something like a threshold encryption scheme or possibly with a multiplicity style scheme that Duality proposed, you can use verifiable sequencing rules and maybe something like protocol own builder to capture that MEV and do interesting things with it. There's also, of course, all the various EPBS, MEV smoothing, and MEV burn schemes that are coming out of the Ethereum world, and maybe those would have some way of ensuring that it gets captured and redistributed in some equitable way as well.
I guess I'll just throw like a contrary point in here, maybe, of like, so from our view of like the idea that like deploying a rollup should be as easy as deploying like a smart contract or whatever the term we use. There's always a question to me of like, who is the rollup? And what I mean by that is like, not the mechanism design of like calculating like the counterfactual of like a single auction versus like a combinatorial auction of like, what is the value that this rollup deserves? But it's a question of like, who is the entity that like represents this rollup, and how is the shared sequencer aware of that being like a distinct entity? So it's kind of this question of like, and Ben, we've talked about this like various research things, like, where do you pay back like the rollup itself? Like, what is the state machine that is like actually calculating and like, receiving these funds and choosing like to distribute them? Like, to our thing, we think from like a UX or like developer experience, it's important that like there's not like a registration phase for like a rollup to like sign up to the shared sequencer. That's kind of intentional, and why we're like a lazy shared sequencer. So to this degree, it's unclear who would be like the valid entity that is being rebated the actual funds, even if we had a magical way to calculate like the optimal value that should be returned. It's like, well, who are we actually giving this to? And then the other point I think of is like, where do we want this value to be like returned to? Should we be thinking about like the rollup as some like nebulous entity or like application developer? Should we be thinking about like the users, right? What if we see some space where, I didn't have, tough time in my talk to cover, but like, what if users are doing something where they have some kind of front end or singular order flow thing, whether it's like Suave or some other kind of aggregation mechanism that is actually using multiple distinct state machines and then settling to a single shared sequencer? Well, that user may not have some kind of like preference for one of these chains versus the other. And so should we be thinking more about rebating the MEV to the users? And again, to Ben's point, right, going to order flow auctions of like, well, actually we're trying to get the MEV fairly back to the user. And, just right now in the current like MEV design, even on like ETH, right, like 90% of that MEV is captured by the proposer. So that's like the entity where you have to get that margin from to get back to the user. But it's unclear if we want like an intermediary hop to like give it to the sequencer or like, the nebulous entity that is the rollup. Really, we just want to be giving it back to the user and giving them like best execution price.
Nice. Okay. So much good alpha right now. Let's focus on based rollups. Based rollups are a critical part of shared sequencing. You can't really have shared sequencing without some sort of lazy execution. So I'm not really sure on the exact definition of based rollup, but effectively you agree on the transactions beforehand and then you execute them. So this is what I think what Josh was talking about earlier on his talk, where you have sort of like an optimistic relay, where you're submitting a block, you're submitting some sort of transactions, and then you have some sort of arbitrary execution environment on top. So another thing to do with MEV is I'm curious on like with this execution environment itself, on reordering the transactions or doing something to do with a based rollup capturing, again, this goes back to like programmatically capturing its own MEV, is can you have a based rollup that doesn't necessarily respect the ordering of the shared sequencer? And can that like be beneficial in any way? Do you see that as like a viable thing? Or, I mean, a very fair answer is no.
No. But, no and. Or is it only yes and? Can we do a no and? Okay, no. Anyways, it gets into the definitions of a rollup can define its own state transition function. So, and that could be on a block level, for example. You could have an ordering of transactions in a block but then an application which reads all those transactions, like takes the average and then uses that to determine like the state of an AMM. So you can define your state transition function to be not just executing transactions in the order that they appear, but it could be some deterministic function of how they appear in blocks. You have to, of course, break it up into some parts. You can't wait forever until you decide what your transition is, but you could do transitions on a block level as opposed to an individual transaction level. And that does give you some ability to define these reorderings, but the key thing is you can't do it in a dynamic way. You can't do it in an opinionated way. Anyone looking at what the shared sequencer outputs and knowing the state transition function knows what's going to happen. There's no like dynamic thing that the rollup can now do. So that's the nuanced perspective.
Yeah, doubling down on that, right? Like the state transition function, like we argue, like it has to be deterministic, right? How you order it, you can just say, I read it backwards. Like why? I don't know, because you choose to, right? Like I think a batch auction is probably like the cleanest thing. If you have like an AMM, like a Penumbra style batch auction, right? Like everyone gets the same price. It doesn't matter if you're at the front of the block or like the back of the block, right? But like it has to be deterministic. You're not like doing like a random shuffle, because again, then the shared sequencer, like again, like what is the commitment giving you? If you're like, someone's going to randomly shuffle it by some exogenous extra protocol rule, you're like, all right, you won't come to consensus on it. Then like, what are we doing here, right? So it does have to be deterministic. Again, like how you order it, how you refund it, like fine. But also from like the shared sequencer perspective, like it's just like including the transactions. It doesn't really care what you're doing after the fact. That's on you.
The name of the concept is verifiable sequencing rules, I believe, and it reduces the problem of fairness to the problem of censorship resistance. If you can get something included, then it will be ordered fairly according to the verifiable sequencing rules. There was a research day talk about it from Matthias. It's quite good.
I'll just argue, I just have a general opposition to like the concept of like fairness being like a thing. There might be some like useful economic definition for it, but like I think arguing of like fairness is where we get like spam and whatever, right? Like all of the first come first serve things of like, oh, is it fair? And like, well, is it fair that the guy has like faster hardware and like a better like a shorter Ethernet cable is like faster than you?
Well, maybe not fair, but something that you can capture and redistribute possibly.
Yeah, exactly. So what I was trying to go with that is that you definitely need a deterministic function, but could you design a deterministic function that can direct value capture to somewhere where you want some sort of programmatic MEV capture? So something like a batch auction, like what you were saying.
Yes, but I think that can only be the value capture within the state machine of that specific rollup. That cannot be the value capture of, say, an inclusion fee within the shared sequencer. Like you on your rollup cannot deterministically reorder something in such that you extract value from like the inclusion fee on the shared sequencer.
Yeah,
I mean, it's also important to note, though, that if you have a deterministic function and you are the protocol or the builder that does have dynamic control over the ordering of transactions that then go into that state transition function, you are the entity that can figure out which order is going to maximize my own profit or which order is going to maximize some profit. So you don't really have control just by defining the state transition function over where the profit goes. And that's why you still need to get back to this order flow auction design that we were talking about.
exactly, because the proposer has monopoly over.
Not the propose. Well, again, so it comes back to consensus protocol. The proposer has a monopoly for one slot, right? Which is important because that means that it will take whatever output it's given if that's the only output from some order flow auction that it can choose from. That's the consensus. That's why consensus protocols. That's why blockchains are good, right? Blockchains turn proposers into monopolists from one slot, and that's why centralized systems are bad because you have a monopoly over all slots. And it's amazing that when going from monopoly over all slots to one slot allows you to achieve non-monopolistic behavior in a system. That's like the coolest economic thing about blockchains. But you still need to solve this like builder side. You need to solve this order flow auction that designs a system which is stable for users if you really want to mitigate or minimize MEV or control where it goes.
Your verifiable sequencing rules they don't know if somebody sold on a centralized exchange after they did a swap, for example.
For example, great.
Which is how all the MEV is extracted.
Nice. Okay, so bear with me. We're gonna bike shed on naming just a little bit.
Fun.
Okay, so I think actually the main criticism of shared sequencers is just the name. So like, do you think that shared sequencing is a good name? Like, is it justified? Or would you rather go with something like I've heard shared proposer, I've heard shared aggregator? Is it not shared seems reasonable, but maybe not even that? I don't know. What do you guys think?
Are we going in order here? Okay. I think that when it comes to names, there's no perfect name for anything. So, I mean, blockchains aren't a great name. I'll say it. They made a lot of sense for proof of work consensus, but you know, other consensus protocols may not be blockchains. But it's the thing that catches on, and it's the thing that resonates with people, and it makes sense. And I think that shared sequencing, we've all now been using it, and of course, once you start using something, people are going to point out reasons why it may not be the perfect term. But in the end of the day, it's a pretty decent term, and sequencing refers really to finalization of the sequence in which rollups will execute their transactions. We could add that to the title. That's a mouthful. And I just don't know if there's another name that's like nice and short and succinct that captures it. But if somebody comes up with one, you're the winner.
I think it's a good name. A lot of people like aggregator. I think that's a good name as well.
I guess I'll say like, yeah, we made like a very intentional decision to like use shared sequencer as like it was like a marketing term, right? But like fundamentally, like people that use the same shared sequencer have a shared view of the sequence of transactions. So like certainly better than like settlement layer, where everyone's like, what the hell is a settlement layer? What are you settling? What is settlement, right? We're like, no. You use the shared sequencer, you and everyone else using it has a shared view of the sequence of transactions that feels pretty explicit, right? Yeah, we implicitly assume that it's like, in our terminology, right, like a lazy, decentralized shared sequencer. But again, you just have to pick words and put it in your marketing copy.
Are there any other misconceptions on shared sequencers that you guys would like to address now?
Shared sequencing is not one rollup. Shared sequence is not shared execution. It's not shared building per se. It makes some set of shared building easier. I don't know. Shared sequencers are real.
Yeah, that's a great segue into. Does anyone know really quick how much time we have left? 0. Oh. Wow. Okay. Well.
Right on time.
Okay, that's great.
I don't know if you have time for the same.
No, there's no need. We don't have time. We were just gonna handle if rollups were real or not. So we'll just leave that for next time. All right. Thank you, everybody. I was super excited for shared sequences before.
Thanks, Evan.
Now I'm extra excited for shared sequencers.